Welcome back to the solutions manual. In this video, we will solve the problem F7-2 from RC Hibbeler Engineering Statics 14th edition. According to this problem, we have to determine the normal force, shear force and moment at point C in this beam. So to solve this problem, first of all, we have to draw the free body diagram. The point A is roller supported, so we just have a vertical support reaction. The point B is pin supported, so we have a vertical support reaction as well as horizontal support reaction. Let's label them. So this right here is AY, this is BX and this is BY. So this is our free body diagram. Now we can use equations of equilibrium to determine these support reactions. So my first equation is summation of moments at point B equals to 0. I am considering counterclockwise direction as positive. So since the line of action of Bx and By is passing through the point B, so these two forces do not have any momentum with respect to the point B. So Bx and By will not produce any moment about the point B. This 10 kN force is trying to rotate the beam in clockwise direction about the point B, so the moment produced by this 10 kN force will be taken as negative. So we have negative 10 and the moment arm is 1.5 meters. This support reaction AY is also trying to rotate the beam in clockwise direction about the point B, so the moment produced by this AY force will be taken as negative. So we have negative AY and the moment arm is 1.5 plus 1.5, so 3 meters. And we also have to consider this external moment, and since it's counterclockwise, so we would take it as positive. So we have positive 30 equals to 0. So upon simplification, AY comes out to be 5 kilonewtons. Now for the support reaction Bx, we can do summation of forces in x direction equals to 0. I am considering right hand side as positive. So we just have a single force which is Bx. So Bx is 0. Now for the support reaction By, we can do summation of forces in y direction equals to 0. I am considering up direction as positive. So we have Ay plus By minus 10 kilonewtons equals to 0. And since we know the value of Ay, so Ay is 5 plus By minus 10 equals to 0. So By comes out to be 5 kilonewtons. So these are our support reactions. Now we have to find the internal forces at the cross section C through the point C. So if I make a section right here, and we can consider either side of this section. Either we can consider the left hand side or the right hand side. It depends upon you. Both will give you the same answers. I'm going to consider the left hand side of this section. So if I draw it separately, then it would look something like this. At the point C, we have a normal force, shear force, and we also have an internal moment, which I am assuming it as a clockwise. This is the 30 kilonewtons meter external moment. This is the support reaction AY. This is the shear force VC. This is the normal force NC. And let's say the internal moment is M. and these distances are 1.5 meters each. So this is our free body diagram of left hand section through point C. Now we can apply our equations of equilibrium. So my first equation is summation of moments at point C equals to 0. I am considering counterclockwise direction as positive. This is the point C. Since NC force and VC force are passing through the point C, so these two forces do not have any momentum with respect to the point C. So NC and VC will not produce any moment about the point C. But we have to consider this internal moment, which is clockwise, so we would take it as negative. So we have negative M. This support reaction AY is trying to rotate the section of the beam in clockwise direction about the point C. So the moment produced by this support reaction AY will be taken as negative. So we have negative AY and the moment arm is 1.5 meters. This external moment is counterclockwise, so we would take it as positive. So it's positive 30 equals to 0. So we have negative M and AY is 5 kilonewtons. So 5 into 1.5 plus 30 equals to 0. So upon simplification, the internal moment M comes out to be 22.5 kilonewtons meter. So this is our first answer. Now for the internal force NC, we can do summation of forces in x direction equals to 0. I am considering left hand side as positive. So we just have a single horizontal force which is NC. So NC is 0. So this is our second answer. And now for the shear force VC, we can do summation of forces in y direction equals to 0. I am considering up direction as positive. So we have negative VC plus AY, and AY is 5 kilonewtons equals to 0. So VC comes out to be 5 kilonewtons. So this is our third answer. So this is it for this problem. I hope you would find this video helpful. If you do, please make sure to subscribe to this channel and also turn on the bell icon for the daily updates. And if you have any questions or any doubts in the free body diagram or in the equations of equilibrium, then feel free to ask in the comment section and I will try to answer them as soon as possible. Thank you.